Alright, welcome back. If you watched the intro videos, if not, it doesn't matter. We're going to jump into C in this video. And before I start talking about details, data structures and data types and stupid shit, we're going to go ahead and just look at a C program really quick, a really simple one, and I will run through it and then kind of explain what's going on. So just try and keep up a little bit and kind of watch what's going on and get a feel for things. I'll go into way more detail on everything later, so if you miss half the video, it really doesn't matter. This is just to kind of get a feel for what's going on. So I brought this file primer. It's a C file in, and so we're going to run through that, compile it, and see what's going on here. So the first thing, I'm including the standard I/O so that we can read and write from files on the screen. First thing we have here is a function. It goes from this brace to this brace. These curly braces are blocks for code. So it'll open up here and then close there, and it'll just say that that's all one block. As far as this line goes, for declaring what the function is, the name of the function is prime. So it's going to tell you if a number is prime, and then it will return an integer type, a number, and it will take in as a parameter or an argument an integer type, and its name is I. So when we go into the function, if I is less than or equal to 1, we're just going to return 0, which is our false value since we're working in C, and I don't know, it's stupid. So 0 is false. If it is prime, we're going to return a 1 as true. And so this little algorithm right here basically goes through and says for each number 2 to the square root of I, if it's divisible by that number, then it's not prime. If we get up to the square root of I without finding that number, then return true. This function again returns an integer, and it's primes from x to y. It takes two arguments, x and y, and then it just calls is prime for each number from x to y. I don't really worry about what all this does yet. And then our main is where program control will actually begin. It's going to say if the argument count is less than or not equal to 2, then go ahead and quit. So basically we want to supply a file name argument. If it doesn't have that, it won't run. It's going to try and open that and then read each line, and then for each line it'll take the two numbers and it'll find the number of primes and then just print it to the screen. So let's go ahead and compile it and see what's going on here. Compile using GCC. And now if we look, we'll have that little a.out file. Whoops. So if we run it now, oh wait, I should look at foo first. So I've got these numbers, 5 lines, 10 numbers, and it'll go x to y, x to y, x to y, and for each line it'll print out a thing. So I'll go ahead and run it, a.out, and foo, whoops, foo.text. And so the number between 2 and 50 of primes is 10, and 2 and whatever, and I don't know what the numbers were, but those are the number of primes between them. So now let's actually look a little more in depth at what the program does. So we'll start at main, and main is defined to return an integer, which is your code for your program, your return code. And basically a 0 return code means that your program exited successfully. If you ever have anything where it didn't work right or you crashed, whatever, you'd return a certain exit code for that, and then you can figure out why it crashed or whatever. The parameters here, argc and argv, this is the count. That's why it's an integer. It's the number of arguments that you've given. And this char pointer is basically a bunch of strings, and those are the arguments that you give in a vector. And so it'll have, right here we're comparing the count, and then, you know, argv sub 0 right here, since we're using zero-based numbers for programming. 0 is the first one in that array of char pointers. That's your file name. The next one will be the first argument, the second argument, third, whatever. And so basically we'll have our 0th one as the file name for the program, and then the first one is the file that we're giving it. And so when we open that file right here, we say argv1, that's the file name, and R for read, and we're just calling some standard C stuff, fopen, a file pointer, fp, and then we can read from it down here, while we can call fgets on fp. We'll scan and print. Char means a character, and this notation right here means 20 of them. So basically this little buffer is 20 characters. We have two integers a and b. This function will take 20 characters from the file, read it into the buffer, and then we can scan as scanf as a string scan, and it'll take something that looks kind of like this, which is basically a digit and a digit, and it'll assign those values to A and B. Down here we have another string thing, and this one is a single digit and a return, line return, new line. So basically it'll print out some number and then return to the new line, and that number is what is returned from this function. So what this evaluates to, so it's actually this int right here that it's saying will be returned. That's what gets printed out. So when the program runs, it looks if the argument count is 2. If it's good, then we can go down and open the file while we're getting things from the file, scan in these A and B, and then print out whatever. And when it gets to this line, it's going to have to call this function to evaluate that, and so it'll send A and B to this function here, and then you'll get x populated right here, and your y parameter populated with your argument b. It'll set aside some space for I, which is just a counting variable. It'll set a total variable, an integer, to 0, and then it'll set your y equal to x. So basically we're going to start at x. This middle part of the for loop is your condition. So every time it gets to the end of the loop body, which is just this if statement, every time it evaluates that if statement, it's going to do this thing, so increase I, and then it's going to check that I is less than or equal to y. So this thing will go from I equals x to I equals y, because when this fails, it'll kick out of this for loop. And then it's calling is prime on I for each one, and if this evaluates to true in this little parentheses right here, then we'll add 1 to the total and return the total. So every time it gets to is prime I, it will call this function here and send that argument I down there to this parameter I right here, and it'll run through this function doing basically the same thing and return the value that we want. So that's basically a simple program and how it runs. Next we'll talk about actual data types and how stuff gets set aside in memory and program control and all that stupid crap.